Hello everyone, July 14th. Alright, let's do today. Oh my god, it's a difficult one. Yeah, we're gonna handle it. It's alright. I dealt with it yesterday. Some fun. Maximum number of events that can be attended. You're given an array of events where events I have start and end and a value. The ith event starts at start day and ends at end day. And if you attend this event, you will receive a value. You're also given an integer k, which represents the maximum number of events you can attend. You can only attend one event at a time. If you choose to attend an event, you must attend the entire event. Note that the end day is inclusive. That is, you cannot attend two events where one of them starts and the other ends on the same day. Return the maximum sum of values that you can receive by attending events. Okay, so the first one, event 0, 1 to 2, event 1 is 3 to 4, but you cannot take the first and second event. So, wait, 1 to 2, oh, 3 to 4, that's, no, wait, that's 1 to 2 and 2 to 3. Times 3 to 4. Oh, what the hell, the way that it's set up. I don't like it. Okay, this is the time. So 1 to 2, that's the second time. So this one starts from this, but this one starts from 3. So I can take these two. So this I can take these two. No, I should take this one because it's better. This I can take all of them, right? 1, 2, 2. 1, 2, 3, 4. But that's not true. 1 to 1. Oh, you can only take 3. Oh, wow. All right. What do you think? Well, it's usually we sort it first. So let's just sort by first. Usually that's how it goes. So we'll sort by that. Okay. And then basically we have, this is my 1 to 2, right? This is a 1 to 2. This is 2 to 3. And this is 3 to 4. All right. And we can say, right, the maximum score we can get if I take this as the last one, right? I take something and that's the last event we take. I want to find a maximum. So now we have a starting point, right? So all we need to find is the previous that ends before this. So if we can have a list of all the previous things that ends smaller than this, let's say I have this list, and I want to find the largest among them. So we want to find the largest in a range, right? The maximum in a range. That's what we want. The maximum in a range. That can be solved using segment tree. So we can do segment tree. So every time you hit 3, then I want, let's see, let's start with what? Start with 1. So I want to find the maximum in range 1 to 2. I want a maximum in 1 to 2. Right? And we find that. Then we can say the 4. We can update what? Update the thing that ending at 4, right? The ending at 4, what's the maximum ending at 4? Yeah, ending at 1, ending at 2 is ending at 4. Can we not do a segment tree? Like, seriously, can we not do segment tree? If we don't do segment tree, what can you do? I mean, what if, dear God, 10 to the 9th. What if we sort based on, what if we sort based on end? Okay, we sort based on end, and the first one come out, but we're not sure if the first one come out is going to be the smallest. Well, I mean, the first one come out will be the smallest. When we sort based on end, and if the end is the same, we sort based on start, right? So doesn't matter, the first one come out. First one come out has the smallest end and also the smallest start, right? So that will say, if we take that, nothing is in the front. And in the next one, so now what we can do, now these are going to be in an array because we sort based on end. So we can actually put the end and the value, right? Next one is the same, the end and the value. And each time when we have the new start, we can binary search this thing to find where. But you still don't know the largest, like say, in this range. I want the largest in the range. This can use BIT though. This can do BIT because what we want to find is just from 1 to 2, right? When we get 3, we want to find the 1 to 2. What's the maximum? I think BIT can do that. I think BIT can do that. We'll do BIT. How do we implement BIT? Like, what if this is if I need to prepare for an interview, I need to know how to write BIT. In fact, I need to not only know how to do BIT, I need to also explain what BIT is. So I mean, it's not that difficult if you look at it, right? It's very simple, but it's not simple, okay? So initialize binary index tree, the size, including min max. Okay, so min max, oh Lord, how do we know min max? We want end, right? So we can go through this to find the largest value. Or we can just go for the largest, 10 to the 9th. That is bonkers. You know, take something, make it 10 to the 9th. Can we even do 10 to the 9th? Will we even allowed? I'm not sure. Times 10 to the 9th. Not sure it's even allowed. Yep. That is not allowed. Dear me. Then what? It's not allowed. Well, maybe we don't need to do this. Maybe we can use a dictionary. Can we use a dictionary for this? Yes. Yes, we can use a dictionary. Yeah, we use a dictionary. Then we don't have to deal with this. We use a dictionary, and this delta, we basically just define the maximum, right? We record the n, so when this is smaller than that, that's really going to be n plus 1, because we'll do this plus 1. Now say if this, just update, right? Because we want to update at a position, and we start from this position, and then we keep going up, because we will be affecting, right? Because from 1 to a certain value, and then we double up will be affected, double up will be affected, everything will be affected down the line. And I don't remember what this one means. Okay, so I need to copy and paste this. You know what? Don't copy and paste. Let's write this. Oh, I mean, if this way, then we can sort by, well, you can sort by front. It will be okay. Would it? No, it would not be okay. You should still sort by end. Right? You sort by end, because every time you had a front, you need to make sure all the end that's smaller than this front has been done before, right? So we need to sort. So dot sort. Sorry, I'm doing it in place. Lambda tuple. So we are sort by tuple 0. No, tuple 1. Right? Tuple 1 and tuple 0. If 1 is the same, we sort by tuple 0. So this is what we first sorted. And then we need to do a bit. So class bit. We do have to have an n. We do have to have an n. Okay, so self.n equals limit. Let's call limit n plus 1. Self.bit equals default dict of an int. Okay, so def update. We had an update position with the current value, right? With the current value, let's call it val. All right, so we say I equals position plus 1, and then while I is smaller than limit, self.bit I shall equal to maximum self.bit I and the current value. Once we're done, I plus equal to I and minus I. Then that is the trick. I minus I, yeah. That's it. And def query. Query, what's the max? The range. High. The range. High. How do I say this? And range and int. Okay. Do we do I equals range end? Plus 1. I res equal to range end plus 1 and 0. Because we're going to record the maximum. And we say while I range end. So what do? We say res equal to maximum self dot limit, no, dot bit I and the res. Okay, and then I minus equal to I minus I. Is that right? This is plus equal self bit I and then I minus, right? I minus, but now I do maximum. I minus this, yep, and then we return rest. All right, let's see if this was right. So we sorted it, and they say bit equals bit. We actually know bit events last one because we sort based on this. So 1, that's the largest. So we have the bit. Okay, now what? Now we're just gonna go for each one, right? For each one, for start and value in events. Okay, and rest equal to 0. Now we're gonna say the start. So what we're gonna do is bit.query start minus 1, right? We're gonna query this, and we're gonna say pre-max, right? Pre-max is this, and then we're gonna say current max shall equal to v plus this pre-max, and the rest equal to maximum rest and current max, and bit.update position is and, right? And the value is current max. Once we don't return rest. Not sure. Let's see if this one works. Seven. 10. Oh, shoot. I forgot to take into consideration. This is not right. There's also K. I didn't even use K. Shoot. How are you gonna use K though? Or at least let's check if the first two works. Ooh, we have a K. Events and K. Nope. Wait, what hell? But 2 are given. Events minus 1. What happened? Events minus 1. Oh, I forgot the self. Oh my god. I forgot the self for all of them. Jeez. Yep, it does work, but the third one does not work. Yeah. So, what do you think? We have to think about the K. Jeez, man. So how do we, I mean, we can know. Ugh. Jesus. So what if we man, you this K is really pissing me off, man. So what I can do with this is at each end position, I record the largest. But I want the largest. But not only largest, I also want to know the largest. I mean, at each position, we shall find the largest with, because you cannot, if you have k, right, then it cannot be used anymore. So in each position, we shall find the largest with k minus 1. The largest with k minus 1. Okay, so basically the largest with a certain amount. Okay, with a certain amount. So when we hit a new one, let's say we hit a new one, and all the previous one is now larger than k minus 1. So I can do them, and I get to k. But what is the largest for me with k minus 1? K times event's length is smaller or equal to 10 to the 6. I need to use that. It seems like a DP thing here, right? It seems like a DP thing. K and event's length index, right? So maybe add in. So we probably have to rethink this. Rethink this. Can we say at an index? Okay, at an index, we say ending at this. We still sort the same way. We're ending at an index with something remaining. Now, what is the maximum we can get? What is the maximum we can get? Well, we're ending at index with current is the ith, right? With the jth event at a 10. If this, right, the maximum we can get at taking this event, and then we treat this event as the jth event. This is what we are right now, right, at this event. Okay, so when we know that, so what we want to do is let's find out this. This is what we'll find out. What is this, the maximum? So what we need to find basically is the maximum dp 0 k, right? The first, the second, the third, right? That's what we want to find out. Okay, so to find this, right? To find this, what do? I'm at some event, right? I'm at some event. I'm at this event, and I say I want to find at this event. I mean dpi 0, simple. It's just that value. dpi 1. Actually, no. If we want to do cache, so this is actually should be remaining. How many events remains? So this is dpk, right? dpik is fine. 3 remaining. Actually, no, it's not 3 remaining. How many remaining? So at this should actually be dp2. So when we start, is this one with 3 remaining. Okay, this one with 3 remaining, and we can take this one, which means this is the first one. That's good, right? We can take this as that. Or you're saying you can take it or you don't take it. You take it or you don't take it. Now you multiply by 2. You further multiply this by 2. No, we say we'll always take it, right? If we take this event, I think I'm thinking about it differently. I don't know what. Nah. Let's think that this is the jth. This thing they show. So if it's 0, 0, and I guess it's fine. If it's a 0, the zeros, so it's easy. It's just by itself. So right. If it's 1, all right, you probably can draw a table. This is the events index 0, 1, 2, 3. This is index, right? And this is the 0th event, first event, and the second event. So the 0th event, these are easy, right? 0th event. Now we do the first event. We say this 0 is first. That's not possible. 0, 1, 2, because 1 you have a 0. Then you are the first one. You cannot be 0. Then nobody in front of you. So this is actually not possible. And of course this one, you cannot be the third, right? Okay, so we can cancel these out. That should be easy to do. So this cannot be larger than your index, right? This cannot be larger than your index. It can be the same as index. So dp11. So what's dp11? Well, dp11, let's say, is if I want to take something, which is the second event, okay? The second event as the second, that means we have to take the one previous. So now you need to know if the one previous, if you can even take the one previous, and you know the one previous has the smallest. No, it's actually the biggest this possible. You have to take everybody. So you have to check this, right? You have to take this. So if it's the same, then you're gone. So this is right, just like no, not possible. If it's possible, then you can get this one, right? So now you're here. You're the third event, right? dp2. You're the third event, and you want to take it as the second one, right? The third event on the list, but you want to take it as your second event. So when that happens, you have choice, right? You have choice. You have boom, 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 choice. You can do basically, so you're here, right? This is where you are. You want to find this, and you have a list of the events previously. You have these. So at the zeroth, you want to find out who has the maximum, right? At the zeroth, who has the maximum in this range? In the range of 0 to 1, who has the maximum? Who has the maximum in the range 0 and 1? Hold on. It's not really who has the, is it who has the maximum? 0 to 1? It is what a maximum. So, which means when you say dp at some value, right? Some value, and you're at something, then what you need to find out is in the previous event that everybody takes, okay? And you have everybody. But that's everybody. Ending at this. What is the largest? Right? What is the largest? Ending at this. And we want to find the largest in this range. Yeah, we can find the largest. We don't even need to use bit. I think a prefix max will work. Because all I want to know, when I'm here, right? When I'm here, I'm the second event I want to take. The second I don't even know how to explain this, but this is the second event I want to take. And then overall, I have like these events to choose from. These are the previous events that I've taken, Okay, these are previous events I've taken. So now what I want to know is among these, which one give me the largest value? I will take that value, I will get it here. And then this will be the largest value I can take as the second event overall taken if I take this, right? And this one will also be the previous max. So previous max. So we also always do previous max. That seems likely, but I want to swap it, right? Well, I want to do it this way. I want to do the columns as the events. 0, 1, 2, 3, 4, 5, doesn't matter, right? And then the rows is the total number of events that I'm allowed to take, right? So that's the 0th event, first event, the second event I can take. So everybody 0, they're the first one, that can go. Here, 0 cannot take this, 1 cannot take this, and everybody can take everybody else. And every time when I'm here, what I want to find out is the maximum of this. But, it's actually more than that. You need to binary search it. Because this is sorted based on the end, right? So we have end, 0, and 1, and 2. So this is this. So now when we given this, we have a start. We need to know which end I can use. So in the binary search, to find where you can do, then you go inside to find the maximum. So this is the max value you can get, taking this as the last event as this event. I think we have an idea. It's actually a good question. Okay, I think this one will work. First of all, no BIT, but it's good. We'll kind of go through BIT again. This is the good sort, so we'll keep that. And we need a DP for sure. And the DP, actually, we only use one of them, so it's fine, right? It's fine. And what is K? The maximum you can take, right? Well, you always want to take more, because take more is definitely not going to hurt. So DP is going to be 0. It's actually not 0. I can't just say for E in events. Nah, DP with this. Actually, events 0. 2. That's the first value, right? And then we're just gonna go for I in range 1 to len events. Let's get that into an N. Okay, then DP dot append maximum DP minus 1 and events I 2. So that's the first level, right? So DP I is the max value obtainable among events 0 to I at the current just I do that, right? That's max attainable. So we just do max. I think max will work. Now we're gonna do real DP here. So the DP is gonna be for J in range K minus 1, because we already done the first one. So K minus 1. Oh, and I also have res is gonna be equal to 0, right? And then res equals to max. Oh no. Res is just gonna be DP the end. Right, res equals to DP minus 1. Alright, so now I'm gonna do J. So for this, And then for I in range, again, we're gonna start with, actually j should be 1 to k. Sorry, 1 to k. So that should start with j to n, right? Start with j to n. So now we need is from bisect import bisect left. Okay. So we'll do bisect left. So now I have a j. Now we know start, end. You don't even need to know end, just a start. End value equals events I. Right? I'm at events I. I have a start, I have an end. So I need to find index equal to bisect left events. I will search for the start and the lambda equal to, no, key equal to lambda tuple. We're going to do tuple 1, the end. So this will give me an index, right? Give me an index that points to a event whose ending time is larger or equal to. So we're gonna do index minus 1, right? Index minus 1. Index minus 1. So if we do index minus 1, right? We do index minus 1. Do we use the same DP? Can we update this thing? I don't think so. So let's do a temp. So temp equal to 0 times n. Okay. So index minus 1, right? Index minus 1 is the previous. So if index minus 1 is, so if the current starting time is smaller than any of the end time of the previous, so it doesn't find anyone that can allow it, right? That can allow it. If that is the case, oh, and that is the case, then what? If that is the case, hold on. So the first is everybody is the first event. So now you is the second event, right? And if you are the second event, and you will need to find a previous event. If there's no previous event, right? If there's no previous event, then you just become 0, right? You just become 0. Or you become, what do you become? Because in the future, you're just saying that you cannot be used as trouble. So what if we have an event that is, we sort by end, right? We sort by end, and somebody just extend all the way to the left. You know, somebody just extend all the way to the left. They'd extend all the way to the left, and that is like one event. And it can be the first event, but it cannot be the second event. So what value? So like I say, this one I want to be the second event, but I can't. So it will be 0, right? If this serving as second event, it will become 0. And then as we're going on, somebody in the future, they want to use, okay, so they can, so they will be able to get it. So but the second event, this one, the second event is going to be 0. So it's just going to be ignored. So somebody in the future trying to find we might find somebody is the second event. So this one will not be the second event, so it will be ignored. I think it's fine. I think it's fine. So I think what I do is if index, right, is larger than 0, because index cannot be 0. If index is 0, it just means the starting is the smallest, right? So if index is larger than 0, then we can say dp index minus 1. That, right, that one will record the maximum from everybody. The end time is smaller than the starting time. So this should be the maximum. So we can say this, well, plus the current value, right? This plus the current value. And temp, right? Temp shall temp something shall equal to this maximum. No, just equal to this. So temp I shall equal to the previous max plus this. But no, because this shall equal to maximum temp I minus 1, right? I minus 1 and this. So it's a prefix max. The previous, and this is the maximum I can get for what we are right now, the maximum we can get. And then temp I will equal to this. Okay? And once we're done, we'll go on, we finish everybody. And actually we do have to. So if this else, then temp I shall just equal to temp I minus 1. We have to continue with this. So once it's done, we say dp equals temp, and eventually we return dp minus 1. So we don't do this, we do this. Does this one work? It should almost work. It's work. The second one doesn't work. What's the second one? Oh yes, I know why. Because the rest shall equal to dp minus 1. And this, when you say rest equal to maximum, rest and dp minus 1. And we'll return rest. There we go. Okay, let's give this a shot. Wasting on you, wasting on you all of the time. Wasting on you. Yeah, this is, I mean, it's complicated, but it's not unsolvable, right? It's complicated, but not unsolvable. Initially, I was going for... Actually, it was wrong, because you don't need BIT, right? It doesn't... You just prefix sum will be good. The biggest hint is that len events times k smaller or equal to what? 10 to the 6, right? This means, let's just use, yeah, this means we can solve the problem using dp with event index, right? Events index and k as state, right? So we can conceive that dp index, dpij is the max score achievable right? Attending events I as the jth event attended on the day, right? On the day. Now to find dpij, we need to find dp m j minus 1, right? When you find where events m has, where events m now we conceive this as the max score achievable attending events this all the way, attending any event from events 0 to events I as the jth event attending on the day. So to find this, we need to find dpm, right? Where all the events, right? All any events in events 0 to events m can be attended by can be attended with events ji also attended. Does it make any more sense? Yeah. Any event from this to this, right, as the jth event. So if we want to find dpij, so we need to find dpm, the previous, and then any of this can be attended. Yeah, can also be attended. Now this, the dp part is very straightforward. But to find m, we need to use binary search, right? We need to use binary search with the starting time of events I as the target and all the end times, and searching through, right? And search through all the end times, all the sorted end times. Thus, we first sort events by end time. Then we can do a 1D DP. Right. In other words, DP ij is a prefix max, right? From DP 0j to DP ij. We do a 1D DP with the 1D array being a prefix sum, a prefix max. Then we use binary search to find where in the previous DP round we can, the previous DP round we can find the max value suitable for the current event. I don't know. Makes sense? Hopefully. Well, I'll call it MN. Okay. Yeah. DP plus binary search. Oh shoot, my bad. I forgot the log. Login. Oh, it's K. It's already have K. Yeah. Yeah, I do bottom up. I get a start. Oh, from right to left. Yeah, it's different. Count. Yeah, I use. Yeah, it's the same idea. Cached binary search. What's a cached binary search? Each of the n times k states. Yes. The same binary search was being repeated. Pre-compute the results of all possible binary searches over the array and then store the results. Oh. Yep, look at this. We do this every single time for k times. But every time it's exactly the same. Because we did this one already. This doesn't change. Right? We did this already. So we can do this previously. And then we save the value. Optimized binary search. Yeah, I saw by end time. I guess it's fine. They sort by start time. I guess you sort by start time. Then what? You sort by start time, right? And get the starts. Current index from the last one. So the last one is the start. But not necessarily having the last end. And it counters as the first to the kth, okay? Next index. Shall be starts, current index, and 1. You find the next one possible. Ah, I see. You go to the right, but me is kind of looking to the left. Yep. And then dp count with this equals a maximum dp count. The next one. Yeah, so this is either I don't take the current one, right? I don't take the current one, I just take the next one. Yeah, that's the prefix sum right here. Right, so I say I start from me as the count, right? And if I don't take me, so I have to take the next one. Right, I have to take the next one. Or if I take myself, then it shall be the current value plus count minus 1 Yeah, you go from right to left. So yeah, it's count -1, and the next index, the next one we can take. Yeah, you know what? Yeah, I don't quite like this. I don't quite like this idea. I like mine. Holy crap! These are top down without binary search. What? Top down with linear search. How do you get log n? Oh, I think probably n log n is a sort. DFS. Ooh, what the hell? It's always valid by finding the nearest event. Strictly greater than the end time of the current event. Finding the insertion point, yes. We have two options for 0. Take or skip. Attending the next event and gain a value. Skip it and gain a value. Start time of event 1 is not greater, so we cannot attend event 1 after attending event 0. However, the algorithm does not verify this condition and will continue to recursively calculate this, and so on. So we need to modify, adding an extra parameter, previous end time, which represents the end time of the previous event. So that's 3. You're putting in 3 states. Only consider valid events. Smaller than, Maximum value obtained by attending a maximum in the range where the previous is this. Yeah, how is this? You're adding another state. I mean, yes, you're adding another state. And this state represents the previous, right? The previous end time. I mean, I give you that. The previous end time, but it could be a lot of previous end time though. Yeah, I don't think so. The value of each state integer is still only computed once. Yeah, it's computed once, but you're creating more states. The hell? This is not right. This is not wrong. This is not right. But the second call would immediately return since this at the point. Okay, so he is actually trying to explain the previous. Then later we do this. Okay, so if the previous is 11, the second call will return since this is not equal to -1 at that point. Because this is the previous. So if we have a later previous, wait, hold on. As previous, so we come to here, right? So we say, well, the previous is 11. Previous end time is 11. And I look back, right? I look back. If I look back, then we see that the previous already happened, which means 2, 6, right? 2 with the 6th count. This has happened with the previous is 8. So if that is possible, then 2, 6 with previous 11 is definitely possible, right? We do the second event at the 6th count. Second event, the 6th count. That will also be possible. Okay, I think this actually makes sense. It actually makes sense now. Current index count and the previous ending time. If this is the end, or count is equal to k, yeah, that's nothing. Otherwise, event this current at the start is smaller than that's nothing, right? It's bad. It's smaller than the previous one. Then we cannot take, this one cannot take, so we could take the next one with the previous, okay? If it's not equal to -1, then we do this. Yeah, this actually makes sense now. Right, this makes sense. This makes sense. So if for a state, current index and count has already been achieved, right, have already been achieved given some previous ending time, right? But what if my current ending time is earlier? If my current ending time is earlier and it has done as well, if my current ending time, the previous ending time is later than what have been shown before, then yes, I agree. All right? Because I can always go back to that. But if my current ending time is earlier than the previous one. So the previous one, let's say I given an ending time is this, I get this. So now I have even an earlier ending time. So that's also good, right? Because a later ending time I can do. So an earlier ending time we can definitely do as well, right? A definite ending time we'll do as well. And if an early ending time I can do, and I have a later ending time, so it doesn't really matter. It doesn't really matter. All the ending time does is just to check if it can be done or not. Okay, one more time. I have the current ending time, right? No, I have the previous ending time. I want to do myself the current index with a count. Okay, the current index with a count, and I want to do this, right? I want to do this. Now, in order to do this, I need to see who leads to me, right? Who leads to me, and if I have done this one already, which means it's possible with a current count, and whoever leads to me, if it's possible, then I will always be possible. As long as I'm possible, that don't really care, right? I don't really care. Yes. It's not part of the state. The pre-ending time is not part of the state. Yeah, that's the thing, right? That's the thing. The pre-ending time is not part of the state. Its only purpose is to determine whether the current event with the current count can take place, right? As long as dp, right, current index and count is valid, all pre-ending time, right, all pre-ending time associated, all pre-ending time that enables this, that allows, right, that allows this to happen, has the same value. Yeah, that's kind of my understanding. Okay, so we need to do two things. So this is solution 1. We can have a solution 2, but this will be different. Okay, this is different. We don't have to do the prefix sum. No, binary search. K times. Only we can do it. We can do all the binary search once, memorize it, and then use it, later. So I need to do binary search here. So basically for each I, right, I need to know a thing. So memo by shall equal to for I in range n. Well, this one has to go to the top. Okay, for I in range n, actually for start, right, this in events, do this binary search events. So that's the memory memo by. Then we do this, then we do this, then we do this, then we do this, right? And then the end is actually not necessary. We can underscore it, and index will equal to memo by I. And if index larger than 0, I will do this. Otherwise, I'll do this. dp equal to this. So this is solution 2. Yep. So this will be O n log n plus nm. So, yep, k plus log n. I want to save the last solution for tomorrow. Just kind of, go back, do it one more time. Oh, yeah, it's much faster. Okay, well, we'll save this for tomorrow. All right.